now we'll move on to average rate of change. Average rate of change in calculus is similar to getting slope of a line in algebra. The difference is in algebra, when you talked about slope, it was specifically just for lines. The idea in calculus is if we have 2 points on a graph, we could always draw a line straight between them, and the slope of that line is equivalent to the average rate of change between the 2 points. Okay, so first thing, let's remember the formula for slope from algebra. So in algebra, slope was always denoted with the letter M. Every book I've ever seen has always used the letter M for it anyway. And it was basically the change in the y values over the change in the x values. In other words, you've got 2 points. You've got a point x1 comma y sub 1 and a point x sub 2 comma y sub 2. So the change in the y's is like saying y sub 2 minus y sub 1 over the change in the x's is like saying x sub 2 minus x sub 1. Okay, so again, that's from algebra. Okay, we're talking about the average rate of change between 2 points. Okay, so with calculus, again, we're not necessarily going to have just a line. For instance, just in question 1 here, this graph is definitely not a line. It's a smooth curve. If we look at what they're asking for, what's the average rate of change from x sub 1 equal 4 to x sub 2 equals 7? So I want to look specifically at the points on this graph where x sub 1 is 4 and x sub 2 is 7. Okay, so that's going to be this point. X sub 1 is 4 there. It's 4 comma 9, so 4 is the x value. And x sub 2 is 7, so that's going to be this point here. The x value is 7 there. Okay, so specifically those 2 points. So the idea is if we drew a line directly between those, let me zoom in some here. Okay, from this point straight over to this point. Again, that's supposed to be a straight line between the points. If I could get the slope of that line, then I would have the average rate of change between those 2 points on the graph. Okay, so we've got to label these points. So in the question it said x sub 1 was 4, so we can call this point 4 comma 9 x sub 1 y sub 1. And it said x sub 2 was 7, so we can call this point 7 comma 11 x sub 2 comma y sub 2. Okay. And if you think about it, that's everything that you need to plug into the slope formula over here. X sub 1, x sub 2, y sub 1, y sub 2, that's everything we need to plug into that formula. So all we've got to do is plug those values into that formula and calculate. So let's do that. Alright, so y sub 2 is 11 minus y sub 1 is 9. So 11 minus 9 for your numerator, divided by x sub 2 minus x sub 1, so x sub 2 is 7 minus x sub 1 is 4. And if we calculate that, 11 minus 9 is 2, 7 minus 4 is 3. So the slope of that line is 2/3. In other words, the average rate of change between 4 and 7 is 2/3. So it's actually pretty simple. It's literally the same thing as slope in algebra. It's just we're applying it to any type of graph rather than just a line. Okay, so if they give you a graph, make sure you identify which particular points they're talking about. We're talking about the points here that have x values of 4 and 7. So you don't use 0, 17, you don't use 9, 7 because those don't have the correct x values. Use the 2 points that they're asking about. Alright, and after the graphs you'll have some problems where they just give you a function and ask you to get the average rate of change given to x values. So we don't have a graph to look at this time. In number 2, they give you a function f of x equal 3x minus 6. So I want you to recall something from algebra. In algebra, you learned about something called slope-intercept form of a line. That was a line written in the form y equal mx plus b, where again m is your slope and b was actually the y value of the y-intercept. So if you realize that this function is written in that form, you don't even have to do any work here. All I've got to look at is say, hey, m equals 3. There's my solution. Okay. So again, if something's already written in the form of a line, you could write it in slope-intercept form. This one's already in slope-intercept form, y equal mx plus b, and immediately identify the slope without having to do any calculations. Notice I didn't even look at the x sub 1 and x sub 2 values here. It's because it doesn't matter, because this is the equation of a line. It doesn't matter which 2 points you're talking about on a line, you're always going to have the same slope. So I didn't even have to look at the x sub 1 and x sub 2 values here. Okay, so again, if you identify that as y equal mx plus b, you've immediately got the slope. Just look at the m value. Alright, and the last question here is going to be a little bit more work. So find the average rate of change from x sub 1 equal 5.3 to x sub 2 equal 8.2. And they give us a function 7x squared minus 6x minus 7. Well, this has a squared on it, x squared. This is called a quadratic function. So it's not a line. So you're not going to be able to do like you did in number 2 and just immediately pull the slope off of it. You're going to actually have to do some work here to calculate the slope. Alright, so first thing, remember what we need. For the formula, you need y sub 2, y sub 1, x sub 2, and x sub 1. Well, they've already given us x sub 1 and x sub 2. Okay, so we know those. So on the bottom of this formula, we're going to have x sub 2 is 8.2 minus x sub 1 is 5.3. What we don't have is the y values. We don't have y sub 1 or y sub 2 here. So what are we going to put on top? We've got to figure that out. Well, it's simple enough to do. We just have to remember what f of x means. F of x is a notation for a function, but in essence it means the same thing as y. So in other words, if you know the x values, which we do, we could plug them into this function and calculate the y values. Okay, so let's do that for each of these x values. So if I want to get y sub 2, I'm going to plug x sub 2 into this function. Okay. In this case, x sub 2 is given to us in the question as 8.2. Okay, so we want to plug 8.2 in for x in the function. So 7 times 8.2 squared minus 6 times 8.2 minus 7. Alright, now let's go ahead and get your calculator, and you can calculate that. 7 times 8.2 squared minus 6 times 8.2 minus 7 is 414.48. Okay, so that's your y sub 2 value. you can go ahead into the slope formula over here on the right. Go ahead and plug in y sub 2 is 414.48. Then we need our y sub 1 value, so we'd plug x sub 1 in to get our y sub 1 value. In this particular question it says x sub 1 is 5.3. So we've got to plug in 5.3. 7 times 5.3 squared minus 6 times 5.3 minus 7. Alright, so again, just plug it in the calculator. 7 times 5.3 squared minus 6 times 5.3 minus 7. Get 157.83. Okay, so there's our y sub 1 value. So let's go ahead and plug it into the slope formula over here. Y sub 1 is 157.83. Okay, and at that point, we can go ahead and calculate our value for m, for the average rate of change. Okay. So let's plug in 414.48 minus 157.83 divided by 8.2 minus 5.3. Okay, I get 88.5. Alright, so basically the difference in question 3 and say what we did in question 1 with the graph is, in the graph you're already given the y values. You actually have to calculate them here in a question like number 3. So right here and here we calculated y sub 1 and y sub 2. So plug those x values in the original function. That'll give you your y values, and then you can plug everything you have into the slope formula. All right, good luck.